Can two numbers add up to 2 but multiply to 3? I think this is a pretty interesting question because when we want to have two numbers add up to 2, I think the natural way to select the two numbers is just 1 and 1, right? 1 plus 1 is definitely equal to 2. However, if you multiply 1 and 1 together, that is not equal to 3. 1 times 1 is just equal to 1. So, no. But of course, this is not the only way to add up two numbers to get 2. We can also have, let's say, 1.5 plus 0.5. That is definitely equal to 2 as well. Right? This is, let me do like this. All right, the other thing we have to do is multiply them. 1.5 times 0.5 is just half of 1.5, which is 0.75. Well, this is 2, but this is not 3. So once again, no. So the question is this possible? Well, I would like to tell you, the answer for this one right here is no. This is actually not possible. However, I cannot just show you two examples and say, hey, it's not possible. I will actually have to show you, convince you with all the work that it's not possible, right? And in fact, I have to be careful. This right here, it's not just no, it's impossible. You will really have to say, no, it's not possible if you just use real numbers. No, with real numbers. So what that means is, if you use complex numbers, in fact, we do have a pair of two numbers that they add up to 2 and they multiply to 3. So let's see how we can do it. So firstly, we want to have two numbers. I'm just going to call them x and y right here, right? X and y. So I need to have x plus y. That has to be 2. And then when they multiply, that has to be 3. So we have a system of equations. And this is a nonlinear system of equation because we have x times y. To solve this, we can use substitution. Subtract x to both sides. So we get y is equal to 2 minus x. And then if we plug in 2 minus x into this y, then we can just deal with one variable in an equation. So it's doable. So we have x. Y is this. 2 minus x. And that is equal to 3. Distribute. 2x minus x squared is equal to 3. Alright, and then this is a quadratic equation. I'm just going to move this and that to the other side. And I'm going to write down the other side first. So we get positive x squared minus 2x, and then still plus 3, and that is equal to 0. Okay, this equation looks factorable, but it's actually not. This is just 1, and this is 3. And in fact, the funny thing about this right here is that you could have gone from here to this equation right away. If you know two numbers multiply to 3, you can actually have the constant term of the quadratic being positive 3. And if two numbers add up to 2, they are just like the solutions of this quadratic. You have to negate that. You get negative 2. And the idea behind that is called the Fieta theorem. But anyways, you can also do it like just like this. But anyways, this is not factorable, so either the quadratic formula or completing a square. Completing a square is better because we have a 1 in front of the x squared already, and also the coefficient of x is an even number. Completing a square would be much better. So I'm going to move the 3 to the other side. X squared minus 2x. Leave a space, and we get negative 3. Okay, we need a magic number here. The magic number is you take half of the coefficient of x, which is negative 2. Half that. And then square that. So that's negative 1. Square that, we get 1. This is the number that we have to add to both sides. So go ahead, add 1 here and add 1 here. Okay. The left hand side, if we factor it, we get x minus 1 times x minus 1, which is just x minus 1 squared. And that is negative 2. Solve this, take the square root to both sides, put a plus or minus, cancel. We get x minus 1 is equal to plus or minus square root of negative 2. Add 1 to both sides, we get x. It's equal to positive 1. plus or minus. Notice how we have a negative number instead of the square root. This is why we do not have real numbers for the solution here. So to get complex numbers, we will have I and then square root of 2, just like that. Now, if you look at, we have x equals 1 plus or minus I square root of 2. What is y though? Well, y is just going to be 2 minus x, which is 1 plus or minus I square root of 2. So 2 minus 1 is still 1. That's good. But if I negate it, the minus times positive becomes negative. Yeah, I know it's weird, but then minus times minus become plus. So it's a minus plus, you just change it. And then we have the I square root of 2. So the answers are the following. I'm going to write it down for you guys right here. If I put x equals 1 plus I square root of 2, then y, the corresponding value will be 1 minus I square root of 2. If I put x to be 1 minus I square root of 2, then the corresponding y value will be 1 plus I square root of 2, which is really just these two numbers that we're talking about. So these right here are the answers, and you can call them the complex solutions because we have the I right here. Pretty cool, isn't it?